This call is now being recorded.
Hello, sir. Am I audible to you?
Yes, yes.
Yes. Hello, everyone. Mr. Sandeep Babar from Shilpa Biological Private Limited at Dharwad, Quality Assurance Manager. He will be guiding us for MSc2 skill course. And now I'm starting with the screen presentation. Sir can conduct the session. Sir, is the screen visible to you?
No problem. I have a parallel screen available here. No issue. Yes, it is visible.
Okay, sir. Sir, you can start with your session, please.
So, thank you everyone for giving me this an opportunity to present a presentation on qualification and validation as a part of MSc second skill course. Uh, thank you once again, all team members and board members. So welcome you all. Very good afternoon. So shall I start with the PPT? Hello.
Yes, sir.
So the outlines of equipment qualification and validation, this is the topic. With the first slide, we will go with the major contents. At first will be objective of qualification and validation, then introduction, third point is qualification and validation flow, fourth one is steps of qualification, fifth one is guidelines which are referred for equipment qualification and validation, and sixth one, some of the examples of equipment qualification and validation we have considered as a part of your syllabus, like pH meter, laminar airflow, and steam sterilizer or autoclave. Next slide, please. So continuing with the first point, objective of qualification and validation. Why we have to qualify or why we have to validate any equipment, any instrument, or any system? What is the purpose of this qualification? So the purpose behind that is improvement of overall production reliability and availability. Suppose you don't qualify or validate any equipment, instrument, or system, chances of failure are more, and chances of failure of your batch or any process or any ongoing activity are more. In order to avoid that, we will do the qualification and validation. Second purpose is safety. Suppose you are utilizing any high pressure, high rated, flammable equipment, then you have to ensure the safety of the equipment to the user, to the product. Third point is fewer interruption of work. Suppose you planned any qualification or batch activity, you should not be get interrupted of your planned activity due to failure of the system or failure of equipment. Fourth one is lower repair cost. Suppose before introduction of any equipment, any system into your process or product, you check that equipment is reliable for the proper use, then it will avoid the maintenance, preventive maintenance, breakdown maintenance during actual run of the system. Fifth one is less standby equipment. Suppose you have the validated equipments or calibrated instrument, then you need not require more standby equipment. Suppose you are running the practical session, suppose pH meter is required, so that is calibrated and totally functional, then no need to worry during practical exam that another standby equipment will be required, because you have assurance that that equipment is calibrated, qualified for and released for use. Sixth one is reduction of variation in results. Suppose you will use multiple equipments for a single study, then you have not assurity that result is consistent and reliable. In order to get consistent and reliable result, we have to qualify that instrument or you have to validate that system. And fifth one is greater confidence in reliability of result. So if you have the qualified equipment, calibrated instrument and validated process, surely you have confidence on your result. Last one is validation process is regulated by the guidelines and restrictions set forth by FDA and other CGMP guidelines. So whatever we are using, suppose pH meter as an instrument, conductivity meter, UV spectrophotometer as an instrument, or you considered as a vessels, fermenters, bioreactor, process vessel, buffer, media preparation vessels, chromatography systems, or larger systems like pure steam system, water system. These systems, how to qualify, how to validate and release for use, there are some guidelines set forth by FDA, Food and Drug Administration, and individual regulatory authorities by respective countries also. So USFDA has their set forth guidelines. Then MHRA have for set forth guidelines for United Kingdom. Like our Indian FDA has our Indian Schedule 1 guideline to follow in pharmaceutical industry. So we will move to next slide, please. So now introduction. Now we are talking about what is qualification, what is validation. So first point is calibration. So calibration is applicable to instrument. Instrument means any component which is giving value, which is showing value. You are recording any value like pH meter, conductivity meter, spectrophotometer, colorimeter, whatever they are showing the value, those are called as instrument, and all instruments are calibrated. That is calibration. So what is calibration? In simple way, in calibration, we will use the national standard given by the national standard authority. They are having the reference value. Against that reference value, we will check our instrument is showing how much value, and there is the range given by every national standard for the calibration. Suppose in simple way, we have to calibrate pH meter. So pH meter calibration, we will use three buffers: pH 7.00, pH 4.1, pH 9.01, or 10.0. What we will do, we will put pH probe in pH 7 buffer. We will put calibration and it will show some value. So if you go on that buffer standard or buffer bottle, they have given the limit of that buffer what should be acceptable. Suppose pH 7 buffer is there, 0.02 is the acceptable range. Means if you put pH probe in 7.00, acceptable range will be 7.02 or 6.98. Accordingly, we will calibrate with three buffers, an offset value and pH calibration value will come. As per USP chapter for pH probe, the slope value is 95% to 102%. Suppose after calibration with three buffers, if you get the value between 95% to 102%, it is acceptable. We can release the equipment as calibrated. That is the example of calibration. We can take another example of weighing balance. In weighing balance also, we can use the standard weight as per national standards, and against that we have to check with our balance that whatever variation is coming is within acceptable range. Then we set forth as calibration. So this is applicable to instrument, whatever giving, whatever showing the values. Next is qualification. Qualification is applicable to equipment. So equipment either include bioreactor, fermenter, process vessel, spectrophotometer. So all these comes under equipment. It may includes many of the sensors also, pH sensor, temperature sensor. So what in qualification generally we will do? Action of proving that any premises, system, items of equipment work correctly and actually leads to the expected results. Suppose we can consider as a fermenter. What we expect from qualification in terms of fermenter or bioreactor, that it should give the proper output what we require. It should maintain the temperature, it should maintain the DO, it should maintain the pH, it should operate as per set point given as per our requirement within that anticipated range. That is qualification. In that qualification, there are two parts like installation qualification, operational qualification, and then performance qualification. We will go in detail in later stages. So next point is validation. So validation will be applicable to process. First we have seen calibration, it is applicable to instrument. Second we have seen qualification, it is applicable to equipment. Third is validation, it is applicable to process. Suppose we can consider that autoclave. So autoclave having an instrument that pressure sensor, temperature sensor, vacuum sensor, all sensors. So that needs to be calibrated. Second, as autoclave is a equipment, we need to qualify that IQ, OQ, PQ. Then what is validation? It is process. Means if you want to sterilize any material, you have to validate that sterilized material is getting sterilized due to using my this sterilization process. That is validation. Action of proving in accordance with principles of GMT that any procedure, process, activity or system actually leads to the expected results. Suppose what we are expecting in autoclave validation, that material should get sterilized and it should not show any biological activity. In terms of pharmaceutical terminology, it should not show any growth, and the F0 value, that is the lethality rate, should be more than 24. That we have to consider in autoclave validation. So, uh, next slide, please. So generally, people got confused that qualification is different and validation is different. So qualification is a part of validation. So these are the steps of qualification. Then it will go to validation. So detailed flow I will explain in next slide. So just the difference between the qualification and validation. System must be qualified to operate in a validation process. So if you consider autoclave should be installed, operated, then its performance is checked. Then we autoclave our load, whatever is glassware, media. Then it is released for use. That process is validated and then released for use for actual routine use. So, in short terminologies, qualify a system or equipment, validate a process. So, you qualify autoclave, whereas you validate a sterilization process. So, next two terminology are protocol and report. Any activity, if you want to perform, there should be instruction how to perform. That is protocol. A document that spells out what tests are to be done, collected, and what the acceptance criteria are, and how to document and handle. Suppose I will tell you perform the qualification of autoclave. Then there are different sets of documents, flow of qualification, that will tell these are the documents you have to follow to qualify an autoclave. So that documents I will discuss in next slide. For that documents, any document you are preparing, that is covered under the terminology protocol. So it will give the instruction to follow procedure or any activity in simple. Then next terminology is report. Suppose you are doing any activity as per protocol, as per instructions given in the protocol or in checklist. After completion of activity, you have to prepare a report, that a document in which the records, results, and evaluation of the completed validation or qualification program. It will include the summary and recommendation. What, in short, in report will include whatever we executed in the protocol, what we got the results, what is the output of the study, and what is the recommendation of that study. You have to recommend that this system is released for use. This system is set with this type of parameters. You can use this type of parameters to use the equipment in your routine process. That report will release that equipment for actual use. Can we move to next slide? So this is actually the qualification and validation flow. Suppose any equipment coming in the pharmaceutical system, it has to go through this system. So this will include first is validation master plan. Every company will have the validation master plan, qualification master plan for all equipments entered in the pharmaceutical facility to qualify and release for use. That validation master plan will have the validation policy, what it includes, what equipments needs to be qualified, equipments need to be validated, at which stage or up to which stage it needs to be qualified and released for use. So this is the flow of the qualification, that first validation master plan will be prepared. So now what is validation master plan? Validation master plan is sum total of policy of qualification and validation of the firm. Suppose our firm has having the qualification validation policy. In that, we will document that what and all systems will be there in our facility, like HVAC system, air handling unit, water system, purified water generation and distribution system, W5, water for injection, generation and distribution system, PHG, your steam generation and distribution system, then all compress air system to supply compress air, then process air for process requirement, like you require air and oxygen in the fermenter, that generation system, then QC analytical system, that's sterility isolator, and your pH meter, conductivity meter, spectrophotometer, biosafety cabinet, then laminar airflow. These all common laboratory equipments, process equipment, chromatography systems, bioreactors, fermenters, all systems, whatever present at the company's premises, how to qualify, how to validate, and who is responsible for that validation. Means in validation master plan, we will decide the responsibilities also, like user, engineering, quality control analytical, quality control microbiology. They will execute the qualification. Then engineering will review, quality assurance will review whatever execution is going on. Then quality assurance will approve what is happen. Then report will be released and system will be released for use. That is the overall idea of validation master plan. Every company is having validation master plan, which will give the idea what are the system present in the company, how they are qualified, how they are validated, and how they are released for use for the company. So in that validation master plan, these are the sub steps. Like first step is URS, second step is DQ, third step is FAT, fourth step is SAT, then IQ, OQ. Sometimes IQ OQ is combined as IOQ, then PQ. Next is PRQ. Last one is requalification and revalidation. So whatever the next slides, I will speak about these six steps, 6, 7 steps only. So how these steps are interlinked, I will mention in next slide. I will give the brief idea about these short terms. So URS, that is the first master document you have to prepare before purchasing any document for the pharmaceutical, any equipment for the pharmaceutical industry. User requirement specification, URS. So user has to prepare whatever your requirements, and you have to sign off that document and send to the particular vendor. Suppose I am purchasing pH meter from Thermolab. I am purchasing conductivity meter. I am purchasing biosafety cabinet. I am purchasing LF or fermenter or bioreactor. I have to prepare first this document URS, sign off, send to vendor, and take confirmation that my requirements are fulfilling by your equipment. Then give me the purchase order for that equipment. So this is in short the first master document, URS. I will go in detail in next slide what URS, what it includes. Next is DQ, that is design qualification. Suppose for complex equipment like fermenter bioreactor, this is applicable. For tabletop equipments like pH meter, conductivity meter, spectrophotometer, this design qualification document is not applicable because they are on the these are laboratory equipments. They are fixed design. They will not change as per our requirements. So they don't have design qualification document. So they are laboratory equipments. Next is FAT, factory acceptance test. So if you want to order customized equipment like bioreactor, fermenter, or process vessels, in that what is our requirement is specific to our process. So we will give specific requirements in our URS. In that case, you have to go to vendor side. You have to test the process vessel or fermenter. And
Hello, sir.
hello.
Your voice is breaking.
So, are you getting voice now? Hello? 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 Are you getting voice? Are
Hello.
you getting voice? Hello? Hello? Are you getting
Hello.
Hello?
Yes, sir.
Okay, sorry. Uh, can I continue?
Okay, okay.
Okay. So we came up to DQ. So next step will be FAT, then SAT, site acceptance test. After that, IQ, installation qualification. Next will be operational qualification. Sometimes IQ and OQ will be combined as IOQ, installation operational qualification. Next is PQ, performance qualification. And last point is PRQ, periodic requalification or revalidation. So these in short terminologies, any equipment if you want to release in pharmaceutical use, we have to follow this qualification flow. Now, how these steps are interlinked to each other, we will see in next slide. Next slide, please. Validation documentation relationship. So here is the linkage. User requirement specification is linked to performance qualification. Now we will think that how it is linked. Suppose I have given the bioreactor user requirement specification as I required RPM from 0 to 400. I required tip speed of 0.68 meter per second. I required a MFC, that mass flow controller of air and oxygen, 0 to 20 LPM, 0 to 100 LPM. Whether that requirement is meeting or not, we have to check in performance of qualification of that equipment. When I will do the performance qualification of the bioreactor fermenter, I will check that as per my user requirement, equipment is functioning so that it is meeting my requirements. Then I will release that equipment. So this URS, as per earlier side, after URS, there will be functional specification, design specification. These both are part of design qualification. Then you will ask that what is function specification, what is design specification, what is design qualification. This functional specification and design specification somewhat related to automation part. Suppose I have to run the pressure hold sequence. That automation part is considered about functional specification and design specification. In design qualification, suppose I have to do pressure hold test. Pressure hold test, what we will do in that, we will pressurize vessel and we will keep that vessel for some amount of time, suppose 30 minutes, and we will give the pressure leakage limit like autoclave. So what we will do, we will pressurize vessel up to 2 bar and we will give limit of point, point 0.1 bar as acceptance limit. Suppose if it is leakage more than zero point 0.1 bar, then pressure hold test fail. But automation of that pressure hold test, that pressure hold test having 5 to 6 steps, directly it will not start. Suppose we started the sequence. You consider that we are doing the pressure hold test in automated fermenter or bioreactor. There will be one sequence, that pressure hold test. You have to log in that system similar to our computer. Go to their sequences. So we have to select the sequence pressure hold test. Start. After start, it will ask for parameters. We have to add the parameter like pressure voltage parameter, pressurization set point 2 bar, stabilization set point 5 minute, pressure acceptance criteria not more than zero point 0.1 bar. Then if you continue, the test will start. What will happen after that? Air inlet valve will open. It will pressurize the vessel up to 2 bar. Then it will wait for 5 minutes for stabilization. During stabilization, pressure inlet valve will open. It will stabilize the vessel. After stabilization time, pressure air inlet valve will stop. Then vessel will be monitored for 30 minutes for any leakage. And if a leakage is more than whatever set point we have given, suppose zero point 0.5 bar or zero point 0.1 bar, then it will give the pop-up that pressure hold test pass or pressure hold test fail. Whatever this automation part, how to design that automation part, it will come under functional specification and design specification. And why it is important? This design specification part we will check in IQ. So now how it is related to IQ design specification? Suppose for fermenter, we have given the design like working volume. Suppose we have considered 500 liter fermenter. In that 500 liter fermenter, some headspace is there. Working volume will be 300 liter. Then what is the jacket volume? Then what is the actual sampling volume? What is the operating volume? All these part we have to consider in design specification. That design specification we have to cross check in IQ. Similarly, whatever operational checks that we have given in functional specification, that we have to check in operational qualification. That's why this is called as V model. This is called as V model as per ISP, International Society for Pharmaceutical Engineering guideline is there. In that guideline, for qualification of any equipment or system, we have to follow this V model. So these are interlinked as per our earlier slide from URS, DQ, FAT, SAT, IQ, OQ, and then PQ. Then system will be released. Can we move to next slide? Can we move to next slide, please?
Next slide.
Next slide, please. No. Next slide, please.
Can you see the slide?
Uh, no, madam. Next slide, please. After V model, madam. Okay. Okay, no problem. You move to one slide. No problem. Yes, yes, yes. So whatever we discuss about steps of qualification, that first will be VMT, then qualification, validation. So qualification is applicable to equipment premises system utilities. Validation is a very broad term. It will include cleaning validation, process validation, analytical method validation. CSV is computer system validation. And this is very broad terminology. So I have taken the general points of qualification and validation. In this cleaning validation, I will give the brief idea that cleaning validation is applicable to a cleaning process. What we will do, whatever cleaning process we are having, we are validating that process for its consistency and repeatability to achieve the required cleaning result. In cleaning result, what we will check? pH, conductivity, POC, bioburden, and BET. These five parameters we have to check during cleaning validation. So these limits as per our final rinse water. Suppose I am cleaning as per as a PW as a cleaning agent, a final rinse agent, then I have to check the specification of PW. Suppose I am using WFI as a final rinse agent, then I have to check the specification of WFI in final rinse criteria. This generally companies were using WFI as a final rinse agent, which is having a pH limit of 5 to 7, conductivity less than 1.3 microsiemens per centimeter, then BET less than 0.25 EU per ml, POC less than 500 ppb, and bioburden 100 CFU per ml. So these are the WFI specification which will be used for final rinsing during cleaning validation. In this cleaning validation, overall in all companies, there will be 5 steps: pre-rinse, alkali rinse, alkali wash, acid rinse, acid wash, and final rinse. These are the generalized 5 steps followed in overall all industry. So in this validation, there will be process validation. It is related to process. Then analytical method validation. It is related to analytical methods that need to be validated. And next is CSV, that is computerized system validation. So this is a broad terminology. Computerized system validation means the computerized system are the system which are having one or more automated function control, like SCADA, Supervisory Control and Data Acquisition System, PLC, and HMI, Human Machine Interface, and PLC, Programmable Logic Controller. So, in short way, in simple way, suppose I am operating process vessel or fermenter or a chromatography system through any computer. So that computer have a program. That program will control the operation of fermenter or bioreactor. In that case, that computer is called as computerized system. That includes the CSV, computerized system validation. So this is broader terminology validation. We will first see the steps of qualification. We will move to next slide, please, madam. So this is the first element, that is user requirement specification. We started in our fifth number slide, that qualification flow. So we will ask what is actually URS. Okay, I have to buy the fermenter. Now we'll take the example as fermenter. Now what is EHS, environment, health and safety? What safety features we required in fermenter? It should have safety valve for overpressure. Then it should have safety valve on jacket. It should have safety valve on fermenter lid also. Then temperature safety, anything is there means it should have insulation of pure steam inlet, chilled water inlet. These are the safety feature. Then in that you have to ask for the vendor that what type of insulation you require. The insulation should be like that. It should absorb the temperature of inside line, and it should not give temperature above 40 or 45, which is harmful to the user. These are the safety features. Then next, maintenance AMC PM. We have to consider during preparation of URS that what is the annual maintenance cost of that equipment, and what is the preventive maintenance requirement. Suppose I consider fermenter, they are having operating valve, pH sensor, temperature sensor, DO sensor, pressure transmitter, pressure sensor. They require routine calibration. Suppose steam track for steam flow, they require routine maintenance. So we have to go through that. What is the requirement of that frequency of calibration and maintenance? So we have to consider during years. Then regulatory requirement. What are the regulatory requirement of this use of fermenter? So we have to check in guidelines that any specific regulatory requirement for use of fermenter that we have to add. Then functional and operational. Functional and operational means what we require in terms of operation from fermenter or bioreactor. As I told earlier, we require this much range of RPM, this much range of flow, this much range of DO maintenance, this much range of pH maintenance. We have to decide what is the DO range, pH range, RPM range, airflow requirement range, oxygen flow requirement range, what is tip speed required, what is P by V power by volume required, what is the headspace required, how many exhaust or how many inlet filter required, what is the temperature maintenance band required. These are all operational requirements we have to consider during preparation of URL. Then migration of any electronic data. Suppose a report formatting is there. PHP pressure hold test report. What is required in that? SIP report is there. Sterilization in place. What and all required? Sterilization hold time required. Sterilization start time required. End time required. Report formatting required. Who started the sequence? What is the start time? What is the summary of the sequence? Who has a login in the system? All these data related required, prepared by, done by, checked by, reviewed by, all these requirements we have to specify in terms of data requirements. Then next is electrical. What type of electrical architecture required, what type of safety required. In that electrical, we have to consider the input output devices, means digital input, digital output devices, what these devices are, how much input output devices you required for fermenter. Suppose considering input output devices, pH probe, transmitter, sensor, these are input output devices. These are analog input outputs, which are operated based upon the signal given to them. And the others are digital input output that are on off valves. They will get only on off signals. Then next is documentation. Documentation part in URS we have to define what is required from vendor. From vendor you require design qualification, you require installation qualification, operational qualification, or any other documentation specific to certificates of calibration certificate, bill of material, whatever the component details, that part. Then instrumentation. In this instrumentation, we have to define the ranges required for your instrument. Suppose pH sensor, what range required? 0 to 14. How much accuracy required? How much readability required? How much decimal you required? 0.00 or 0.000. All these details you have to consider for all instruments, pH, DO, temperature, pressure. Last one is 21 CFR. That is important. CFR is Code of Federal Regulation, which is given by FDA, Food and Drug Administration. So in that, two parts are there, 210 and 211. 210 is for API, active pharmaceutical ingredient. 211 is for finished product. During preparation of URS, we have to consider part 11 of 210. That part 11 is for electronic record and electronic signature. That requirement we have to consider during preparation of URS. This is overall structure of URS. Nothing but I am purchasing the bioreactor, I am purchasing the pH meter, I am purchasing the biosafety cabinet. What is required for my use, I have to specify in this user requirement specification. This is a document stating that specified user requirement for a selected piece of equipment, system or person. This is about the year. This is the master document. From this document, qualification activity will start. Next slide, please. Next step, as per our qualification flow, is the design or FS. So this functional specification describe the operation of equipment. As I discussed in URS, I will tell that my equipment require this type of operation and this type of design requirement. That will come in design qualification. What it will explain, suppose a fermenter, I am having the process and instrumentation diagram. It will tell where air will come, where air will come out, where steam will come in, where chilled water come to jacket, where plant steam will come to jacket, where pure steam will come in the fermenter, from where steam will come out, where process fluid will come in, where process fluid will come out. Everything will be detailed in process and instrumentation diagram or piping and instrumentation diagram. Then GA, general arrangement. General arrangement drawing will tell the overall general arrangement of the vessel, that what are the inlet ports are available, what is the size of every inlet port, what is the diameter of the fermenter, how many legs are there, what are the inlets coming, what is the size of the top lead, on top lead how many ports are available. All details will be given in the general arrangement drawing. Then system layout. This system layout will tell how your fermenter, after receiving in the facility, where it will be placed, which is the side, what is the front side of the fermenter in that our room. That location of the fermenter inside our facility in a particular room, suppose within that fermenter room, that is defined, which is the front side, which is the back side, because accordingly that utilities are lined from the top of the top floor. So I have to place the fermenter, then left side inlet utility should come and right side all outlet utility should go. So as per that system layout is defined. Then next point in design is mechanical parts. Suppose I am taking any SS equipment, that MOC is very important. Product contact MOC should be 316 or 316L. That is the category of stainless steel. If it is a non-product contact, it can be SS 304. So these are the categories of stainless steel depending upon the composition of the steel. So why it is 316L? Because it is having low carbon content and it will have resistance to rusting and any other another abnormalities on stainless steel after coming in contact with the power. Next point is electrical drawing. We have to give the details of our electrical requirement. Next is bill of material. It will tell the component requirement, that what type of POs, DO, automation part what we require, means software what we required, which license required, then which how much size of GB data storage required. Automation part includes the HMI requirement, configuration requirement, all will come. Then in instrumentation, it will come accuracy. Suppose temperature sensor, how much accuracy required, range, capacity, response to MOC. Then 21 CFR and hardware requirement. You have to define 21 CFR requirement as per part 11 requirement, that what type of software, what type of version you require, then hardware component, that what type of memory, how much memory, storage space, and then transport portal. Because I have to transport data from this fermenter to another system, that all requirement we have to consider in design qualification. So as per URS, vendor will prepare our system, including all these documents. In addition to that, some manufacturing documents are there, means some welding documents are there. Suppose SS portions are welded, how it is welded, how it is passivated, whether it is clean without any pinhole, that also part of design qualification. Next slide. So after design qualification, as I told earlier, if the equipment is customized equipment, means we have suggested some changes or requirements in our user requirement specification. I require this type of specific test or specific operation in our fermenter. Then I have to go to the factory of vendor and I have to do the factory acceptance test. If it is done at vendor side, it is called as factory acceptance test. And if it is done at our side, means pharma side, then it is called as site acceptance test. This is the checklist. In that we have to check that the vendor has prepared the equipment as per my URS, meeting my design qualification document, and I have to test bare minimum test at their factory. After that test only, he has to release equipment or dispatch equipment and send to my factory at a pharma site. After coming at pharma site also, I have to check minimum wear checks as site acceptance test. I have to do the factory acceptance test. In that, I will check the documentation, identification of the component. Suppose I told in design qualification that I require this pH sensor, this DO sensor, whether it is present or not, whether all the mechanical components fitted or not, whether all inlet outlet lines are correct. Suppose one general example, your steam should come from top and go from bottom. Chilled water should come always from bottom and go from top in order to get hold up. So these are the minimum requirements. You have to check during FAT only. If you come to know during SAT or at the site or in our site in pharma company, then it is difficult to change because modification part is not possible at our site. We have to again send equipment to manufacturer or original equipment manufacturer. So these are the mechanical checks. Then MOC means material of construction, that is SS316L. Then RA means roughness average value. So in generally in pharma industry, whatever product contact surface RA should be less than zero point 0.4 roughness average value. When it is product non-contact, then it will be more than zero point 0.8. According to that, remaining tests are there: CIP, SIP, PST, 21 CFR checks, safety checks, noise level, operation level, then any riboflavin test, hydro test. These are the tests for checking the integrity of the vessels. Hydro test is a water pressurization test. Riboflavin test is a cleanability checking test. Then data storage, backup, all these tests we have to check in FAT and SAT. After these minimum checks, equipment will be transferred to IQOQ. Next slide. So after this FAT, SAT, then it will come at our site in pharma company premises. Here we will do the IQ, documentation training, verification of utilities, whatever utilities required, process air, pure steam, plant steam, chilled water, all these utility, instrument air, then calibration, maintenance and lubrication works. We will check the whether all instruments are calibrated. Then mechanical electrical checks, all connections are done in that IQ. Then all certificates are available. Then weld map, weld log means whatever.
Sir, you are not audible.
Equipment with all components and ready for operation. That is next step, operation qualification. Next slide. Next slide. Okay, this is now operational qualification. Now we have come through URS, DQ, FAT, SAT, IQ. This is OQ. Now what I will check in OQ? I will check the verification of calibration checks. I will check the set parameter, boundary verification, then test all operational tests, pressure hold test, cleaning in place, stabilization in place, transfer sequence, harvest sequence, media preparation, agitation, mixer verification, or user access level. Generally, in operational system or computerized system, there will be four access level: user, supervisor, administrator, and admin or engineer. So these are the different privileges. Means access levels to different person. Means user has to run only sequence. Supervisor has to change the parameter. Engineer has to do maintenance work only. Admin has all rights. These are the four rights given in operation. Then in addition to that user rights, we have to check safety checks, safety wall check, noise level test, operational training, and in all these operational tests, any deviation we have to handle that protocol. These operational tests will ensure that this equipment is ready for performance qualification. In operational checks, we have to check all tests we required. Suppose fermenter I required cascade, means agitation, aeration set point. I have to give that set point, verify that whether that system is running as per set point. That is the operational qualification. Within that range, suppose my pH range is 0 to 14. Within that range, it is operating. Suppose I have given the pH set point 7 and it is going below pH 7. It should ask for alkali to maintain the 7. If it is going above pH 7, it should ask for acid addition to maintain the pH again to 7. Like that, all operational checks similar to DO, similar to pH, similar to conductivity, consider for all. Next slide, please. So next slide is performance qualification. So we will consider as a performance qualification. Now, what is the difference? Already I check IQ, that is installation. OQ is anticipated range verification in short. Now PQ. PQ, we have to check the consistency and reproducibility of that equipment. Means in OQ I check the pH is maintaining 7. I have set the dead band that pH should maintain between 7 plus minus 0.1. So either 6.9 to 7.1. But I have to check the consistency and reproducibility by taking the 3 consecutive runs. That is performance qualification. I have to prove that equipment is consistently giving the reproducible result. That is performance qualification. I have to check the performance. In that, I will check either we can do simulation run, means we can do the buffers or any materials. With that, you can check the performance qualification, or you can check batch. Next slide, please. Next slide. So, next slide, please, madam. Madam. So, what are the guidelines? What we follow for this? So, I will tell IQ, URS. I have to prepare DQ, IQ, OQ, PQ. What are these terminology? What are the documents? So, there are different types of guidelines. So, ISP one guideline is there. Then WHO guideline is there. European Union guideline is there. USFDA, the United States guidelines are there. In addition to that, some of the specific equipments having specific guidelines. Suppose you have to qualify autoclave, there is separate guideline as European norms 285. Then Health Technical Memorandum 2010, HTM 2010, part 3. So specific equipments having specific guideline in addition to these common guidelines for equipment qualification. Now we will move to next slide, please. I will give one example that pH meter qualification. So you will get the overall idea what we'll discuss in just 5 minutes. So, madam, can you go to previous slide? This is airflow. Previous slide, pH meter. So I will explain this simple. So we will conclude all these slides. So I have to purchase pH meter. So what I need to do? First, I need to do URS. It is a tabletop equipment. DQ is not applicable. Then vendor will give IQ document. In that IQ document, I will check everything is there. Then vendor will give OQ document. In OQ document, I will check all the things, that calibration of sensor, then password, printout, login, password verification, draft SOP I will prepare. After this preparation of draft SOP, I will move to PQ, that is performance qualification. I will check the calibration with 3 papers with slope range 95 to 102. Verify all printouts. I will give the summary conclusion that equipment is released or used. So this is the flow of general tabletop equipment. Can you move to next slide, please? Next slide, please, madam. Last slide, madam. Autoclave. So this is the major equipment. We have seen the tabletop equipment. This is the major equipment, autoclave, or you can say steam sterilizer. For steam sterilizer, whatever steps we have discussed, like URS, DQ, FAT, IQ, OQ, PQ, all are applicable because it is customized equipment. Means we have give the specific requirement. Suppose I have one complex material like glycerol, that sterilization time will be more because it is viscous. Then my sterilization time period will be more than 60 minutes. So I will define in my user requirement that this is complex requirement. You design autoclave to meet that this material should get sterilized. So they will give the parameters with lengthy timeline that autoclave can withstand more than 60 minutes sterilization hold at 122 degrees. This is the specific URS requirement. General URS requirement will include what is the size of the chamber, how much material it can accommodate, 900-liter volume, 800-liter volume, 1200-liter volume. Double-sided door should be there. It should have the parameters of standard cycle, then high pressure, high vacuum cycle, leak test, Bovidic test. All these requirements I will define in URS. Then design requirements ISO double-sided door generally required in GMT, that will come in URS. Then they will provide the DQ with all these design requirements like drawings, everything. All they will give certificates. They will give PID, GA, as we discussed earlier. Process and instrumentation diagram. It will explain where steam will into jacket, where steam will into chamber, where steam will out from the jacket, where steam will out from the chamber. How many temperature sensor will be in the chamber? How many pressure sensors? How many safety valves on chamber, how many safety valves on jacket, everything will be given in design document DQ. Then I will go to factory of suppose autoclave vendor machine fabric. I will do the FAT factory acceptance test. I will check all the tests as per factory acceptance. Then we will dispatch equipment to site. Again, I will check the site acceptance test. Sometimes company will leverage site acceptance test and directly go for IQQ. They will not do site acceptance test. They will just verify and they will go for IQQ. Then I will conduct the IQ, that installation qualification. Then I will conduct the OQ, operational qualification. And then I will go for performance qualification. In IQ, as we discussed earlier, I will check all mechanical checks, drawing checks, calibration checks, component checks, certificate checks, MOC verification check, RA verification check. Then after successful installation, successful sensor verification, safety verification, then I will move for OQ. In the OQ, first I will check the calibration, then I will check the test like vacuum leak test, Bovidic test, high pressure, high vacuum test, standard process test, SIP of vent filter test, all cycles with inbuilt sensor. I will check all reports. If all meeting the acceptance criteria, then I will go for the PQ. Here two tests are critical: VLT, vacuum leak test, to check the chamber integrity, whether chamber is integral or not. Second test is Bovidic test to check whether steam is penetrating throughout the chamber and air is not present inside the chamber. After doing this pre-check, we will check the different cycles like standard cycle, gravity displacement cycle for liquid load, and SPHU cycle, high pressure, high vacuum load for non-liquid load like assemblies, glass bottle, which are empty, which are with filters. After checking this OQ, I will prepare a draft SOP and I will perform the performance qualification. That is the last step qualification, performance qualification. In that, I have to check the 3 runs of every load. That is performance qualification. Suppose I have a liquid load, media load. I have a 100 ml bottle and 50 ml of media. I have to take 3 loads of that glass bottle, which showing the consistency that this load is getting sterilized. In that, we have to check the 2 checks. One is biological indicator check and second is chemical indicator check. In chemical indicator, that color change will happen at above 121 degrees Celsius. In biological indicator check, in biological indicator, we have biological indicator Geobacillus stereothermophilus, which is having cell count of 1 into 10 raised to 6 spores present in the spore strips or vials. During sterilization, we will keep core strip of oil during sterilization cycle. After that, we will check whether that all organisms are killed and there is no growth in that spore strip vial. Then we consider that we have got the sterilized load. This is the biological check, and another check is chemical check. Chemical indicator color change will be there. In that autoclave qualification, we have different terminology, Z value, D value, F value, and F naught value. So D value is decimal reduction time. Z value is the time required to get one D log value, and F value is lethality rate. That is F0 value. That is lethality rate. That what temperature we will get required lethality. So generally, F0 we considered as 1 if its temperature is 121.1. So how we have to calculate that how much F0 is required? It is depending upon our bioburden. Generally, companies follows two approach: overkill approach and bioburden approach. Overkill approach means I don't know the bioburden of the material. I considered as worst case that I require sterility assurance of 10 raised to minus 6. As per that, I will design my cycle. Second approach is bioburden approach. I will determine first how much bioburden present in my material, and to reduce that bioburden to zero, I will take the F0 value. That calculation will be there for designing the load. As per that, we have to design the load, whether it is porous or non-porous, it is liquid or non-liquid, and each load we have to take 3 runs, and we have to check the consistency that there is no growth in the BI indicator and there is color change. As per that, we have to release the autoclave. That's it. So these are the overall steps of qualification. This is the generalized guideline applicable to all equipments and systems. Some tests are specific to that equipment that can change. Okay. So this is overall from my side. If anybody has questions. Hello. Hello. Hello.
Yes, sir.
This is complete. This is completed from my side. Any question you can ask, or it is completed?
Unmute over the right side. Thank you, sir. Now session is open for discussion.
Okay.
Okay, there is no question. So, on behalf of Department of Microbiology and YCIS, I am grateful to Mr. Sandeep Babar sir for being with us today. Thank you, sir, for explaining nuances of instrumentation and validation. I am sure our faculty have acquired insights to conduct the syllabus effectively. I take this opportunity to thank Principal Dr. B.T. Jadhav sir for encouraging us to conduct such a faculty development program. I also thank BOS Chairperson in Microbiology, Dr. Mrs. S.S. Kanse Madam, Head of the Department, Mrs. N.S. Joshi Madam, all my colleagues for being a part of this program. Thank you so much. Thank you, sir.
Thank you once again for giving me this opportunity.
Thank you, sir. So we will stop over here.
Okay. Thank you.
ओके सर चालेल आता आपण लिव्ह झालं तरी चालेल सर
Okay. I will leave.
recording.